Hello everyone. Today we are going to discuss fuse, electrical fuse, which is a safety device of the circuit. Why? Because it acts as a safeguard to the circuit and to the appliances. And here is the weakest point. It is the weakest point of an electrical circuit. And also we can say this fuse melts and breaks the circuit and breaks the circuit circuit. Okay, means this is the breaks the electric circuit. Okay, so fuse, it is the safety guard, it is the safety device of this circuit, and that appliances, we can say it is the weakest point of this electrical circuit. So what is the material it is used for the fuse wire? Actually this is a short thin wire. It is an alloy. It is an alloy. Alloy of what? It is the alloy of lead and tin. Lead plus tin. Here we can say this is the combination. This is the alloy of lead and tin. Here it is the 50%. Here it is 50%, 50%. Okay, it is the combination of, this is the alloy of lead and tin here, and here this is a short and thin wire of uniform cross section area, of uniform cross section area. Okay, this uniform cross section area is also important because this one varies, then resistance varies, and accordingly current also varies. That should be, here it should be uniform cross section area. If we are considering the material, what should be the characteristics here? Characteristics of fuse wire. What should be the characteristics? It should be of low melting point. Here it should be of low melting point. Low melting point. And the second part, it should have high resistance. It should have high resistance. The melting point, so that more current passes, more heat will be generated, and this one will melt, and it should be of high resistance. And here, why this one of low melting point? Because more current passes. See that one here, I is more. Okay, more. According to that heating effect, H equal to I square RT. Okay, so here more will be the current, here more. So when heat will be more, then if it will be low melting point, then only this one will melt. Okay, so that here, let me write here low melting point, so that it may easily melt due to overheating. When current in excess, current in excess to the prescribed limit, it passes through it. Okay, so that this one will be, so that is why low melting point here it is taken. Here why it is taken of high resistance? So that here temperature will be more. The same thing, see that one here, what it can be, H equal to I square RT. High will be resistance, more will be the heat generated, here this one will be low melting point. So that is why here what we can say here, so that here high resistance, so that its temperature rises rapidly, So what is the principle of fuse? So it works on the heating effect of current. Now we have seen Joule's law of heating, H equal to I square RT. Depending upon that one, this one will be principle. We have discussed this fuse wire. It is an alloy of lead and tin. Okay. So if what will happen if we will use copper wire or aluminium? Can we use copper wire or aluminium wire for the fuse? The answer will be a big no. This cannot be used, because what is the reason behind why we cannot use? Because this copper wire or the aluminium wire has high melting point. So if this one will be high melting point, this cannot melt. Okay, but this copper wire and aluminium wire are the good conductors. Means its conductivity is more, so it is used for the transmission purpose. This can, if I am using a fuse, to which wire this fuse should be used? We have live wire, we have neutral wire, and we have earth wire. Okay, so fuse should be connected to which wire? So here fuse should be connected to the live wire, because here in live wire current passes through the live wire, and here let me have this one will be the live wire. Here the fuse I have taken, here this one is the fuse, this one goes, this one let it be the bulb or let it be the resistance, whatever it is there, and current flows, returns here, enters and returns. This is the neutral wire. So when current passes, and here all these fuse, they have their particular rating. We will discuss that one. This according to the use of these appliances, what appliances we are using, how much current these appliances will use or it will draw, accordingly fuse can be maintained. Okay, we cannot use more than that, we cannot use less than that. So okay, let it have a particular amount is there, accordingly we are taking this fuse. Now as it has this low melting point, okay, so when more current passes, then what happens? This fuse blows off. This one will not work, this one will melt, so that this one becomes open circuit. Current cannot reach to the resistance or these appliances, and this appliances is safe. Now question arises, if it is like this, here also current passes in the neutral wire, can we use that? Okay, let's see that what happens here. Here I have taken this one. Okay, this is the fuse that I am using here. Now current passes, let it be, it exceeds, it comes, this one, if this one will melt. Now what happens? This appliances always will be in connection with the live wire, so that whatever current flows here, this resistance will have that much of voltage or the potential with that, so that anybody will touches will get the shock here. Okay, if more current also passes, then there is a chance to this device also can damage. This is the reason only why it is connected in that live wire, not in that neutral wire. This is the confusion with the students. So live wire, when it passes, as it is the safety guard for this device, first of all it will blow off, it will not allow more current to pass through the device. So this one will be open circuit. Here what happens? Current flows, device will damage, then it will come here, this one will fuse, or if it is maintained, always this one will be in connection with the live wire, so that anybody touching here will get the shock. See, current rating of an fuse. What do you mean by current rating of an fuse? One important thing is, this fuse whatever we are using, depending upon the device which draws how much amount of current. Okay, so here the fuse rating means the maximum current which can flow through a fuse without melting it, because it has the low melting point. Current exceeds, it will melt. So whatever it is without melting, how much it is current is drawing, that is known as rating of the current. And here the formula of current, P equal to VI. So current we have to find out. So I equal to how much implies I equal to P by V, yes or no? So this is the formula we will use, and here current rating I equal to here power, total power of these appliances and voltage of this supply. Here, whenever a device or the appliances, electrical appliances we purchase, any electrical appliances, there will be something back, it will must be written here, that is the power and the voltage. Let it be, we are taking something which is 15,000 watt and 220 volt. What does it mean? It means that power of these appliances is 1500 watt and voltage equal to 220 volt. So now here question arises, how much current it can draw? We know P equal to VI, so I equal to P by V. So here what we can put, P equal to how much? 1500 divided by 220. So 150 by 22. Here it will be 6 point something some ampere of current it draws. Understood? So here the important thing is, whenever we are using the different appliances, let it be using TV, using the refrigerator, using that AC, all this, let it be the bulb, electrical bulb we are using, or fan we are using, all the cases there will be different current supply. So whatever fuse it is needed for TV, that is not required for AC, means this AC cannot work. Here if we are taking for whatever for AC, that is unnecessary or useless for TV. Why the circuit breaks or the fuse blows off? Let me see why fuse blows off. Okay, so now let us see this one. There are so many reasons are there for it. Here it can be overloaded, means overloading also we can see. Second one, it can be short circuit. Third one, we can say this one is due to the voltage fluctuation. This is due to the voltage fluctuation, or we can say that one here fluctuation in current. Obviously this voltage will fluctuate, means current also will fluctuate. Okay, fluctuation of current we can say. So now let us see what is overloading. Overloading means here for a particular switch or particular when connection is made, there will be permission, or the amount of current drawn will be fixed for it. So more than that current whenever it is required. For example, in one room or one connection we are using the fridge or refrigerator, or fridge we are using some TV we are using, another electrical gadget, another electrical gadget we are using. This is permitted for that. And sometimes we have seen, if we are using an iron box or pressing that appliances we are using, okay, in that case most of the times when we switch on, then there will be fuse blows off. Okay, what is the reason behind it? Because it draws more current, which is not permitted for the particular circuit. Okay, that is why the fuse blows off. This is known as overloading, because it is load is more in this case. Then let us go for short circuit. So in case of short circuit, what happens? This when more current passes through this wire, then here this copper, the conducting wires are copper wires. So insulation of this copper wire breaks. Okay, so insulation breaks. when insulation breaks, live wire plus neutral wire, they come close to each other, they come in contact with each other. So when they come in contact with each other, area increases. Area of cross section increases means it becomes thick. When it becomes thick, it draws more current. It draws more current. That is why only the short circuit happens. And voltage fluctuation, you know, whenever there will be up and down current, all those things, that time fuse blows off. Now what is the working of the fuse? How it works? Now by due to any reason, maybe the high voltage short circuit, now we have discussed, let it be overloading, let it be the fluctuation, voltage fluctuation, whatever it may be, when the current exceed in the circuit, there will be a specified value for the circuit, no? So when current exceeds the specified value, the temperature of this fuse wire rises. So when temperature of the fuse wire rises, and we have taken the fuse of low melting point, okay, so here what happens, this temperature of this fuse wire rises, and as a result what happens, this fuse blows off. As it has the low melting point, fuse blows off, a gap is produced, because see that one, if we have taken this one, we have discussed live wire, this one is the fuse, here there will be appliances, let it be resistance I have taken, this one will be any appliances, this one will exceed, there will be blow off. So now what will happen, see here, this one, a gap will be maintained. So when gap will be maintained, this one becomes open circuit, and now current does not flow through the live wire, and this appliances is safe now. Clear? Understood? Now let us see here, when we are talking about fuse, one important thing, remember, this fuse, this current rating of the fuse is different for different appliances. It is not same for all these appliances. For TV, for fridge, for this calling bell, let it be that AC, let it be induction chula, whatever we are using, for everything there will be different rating. And here if it says this is 15 ampere, fuse rating is 15 ampere, it shows that maximum of 15 ampere of current can pass through the appliances, not more than that. If it exceeds, then this one will blow off. This is the working of this fuse. Okay, and here there are different type of fuse. Here we can say this one will be cut-off type fuse, we have to take it out, and another one it can be cartridge type. And here this cartridge type fuse is usually, it is found in all these appliances. This one will be just, this one will be small, and here they made up of glass, small one, and here in this case this portion will be steel, here this one will be steel, and here there will be one wire will be connected. Some cases there will be small piece of paper inside, some cases here on the steel, that one will be written 0.3 ampere, 0.03 ampere, like this one will be cartridge type. And now everything it is replaced with MCB. It is easy to use, easy to repair, all the cases.